All right, well, here we are back again. I promised you some practice problems that use the equations that we just derived in the last video. So in the last video, we looked at how there's a whole lot when we say acceleration is a change in velocity divided by a change in time. There's a whole lot in there. And so we had several equations. I'm not going to write them out right now. What I'm going to do is I'm going to use them in a couple of problems. So let's think of a scenario. So say we have a couple of lovely girls. And so girls have to be drawn like this. And there's the hair. And so this is one of our lovely girls. Let's just call her Becca. Okay? Just because she needs some hands. Sorry, Becca didn't have hands. And let's say that there's another lovely girl. And let's see, we'll make her a little bit taller. And let's call her Sarah. And both of these are extremely lovely girls. And let's say that these two girls are playing basketball against each other. Okay, and so here's our hoop right here, and there's a backboard and such. So let's say that, Sarah doesn't have hands. They're there. And so let's say that that Becca decides to throw the basketball at the hoop. So here's our basketball. And so Becca throws the basketball at the hoop. Woo! Misses the hoop. And the basketball lands on the ground right here. Okay? And the basketball continues to roll. Continues to roll. And let's say that it has a constant velocity here of 1.75 meters per second, okay? And so it's rolling away, and so Becca and Sarah say, well, what should we do? And so they notice that right after the basketball is a little bit of a slope right here. And so what they figure is going to happen is that the basketball is going to go up that slope, and eventually it's going to stop, right? And it's going to come back down, and they're hoping it will roll right over to them so they don't have to run over and get it. And so this is their plan. So anyways, so what happens is that basketball has an initial velocity of 1.75 meters per second. And so as it starts up the incline, it will begin to slow down. And so let's say this incline causes a constant acceleration of negative 0.20 meters per second squared. So that's going to be the constant acceleration of the basketball as it goes up the hill. So here's the question. The question is, could we figure out then how long Becca and Sarah are going to have to wait until the basketball starts to move back down the incline? And we could actually figure out a lot of different things. But let's just say we'll look at how long do they have to sit here and wait before they see their basketball start coming back down to them. So how are we going to solve this? Well, here's what we have. We have an initial velocity, which is 1.75. We have a constant acceleration, which is going to be negative 0.02 because it's going to be slowing it down. So I wrote that as a negative. If it was speeding it up, it would be a positive. But since the acceleration is in the opposite direction, it's going to be a negative. And we want to know when that's going to start rolling back. So the point at which that starts rolling back is going to be when its velocity in the forward direction has gone down to 0. So at the point that that basketball's velocity is 0, it's going to start rolling back down to Becca and Sarah. So there's our final velocity. We know our initial velocity, and we know our acceleration, and we want to know how long are they going to have to wait. So if we remember our equation, we had final velocity equals initial velocity plus the constant acceleration times the final time. So this is what we want to know, is our final time. That's kind of the variable that we're looking at. And look at, we already know the pieces to this puzzle here. So our final velocity we want to know is going to be 0. Our initial velocity is 1.75 meters per second. And we're going to add to that a acceleration of negative 0.20 meters per second squared. And so then that's going to allow us to solve for our time final. All right, so simple thing to solve, not too complicated. We could go ahead and move this over here to this side. So negative 1.75 is going to equal negative 0.20 times t. And so we could divide both sides by negative 0.20. And what are we going to find out we got? Well, lo and behold, that's going to take 8.8 seconds. So they're going to have to wait a while, and then they're going to have to continue to wait as it comes down, because if it takes 8.8 seconds to slow, it's going to take another 8.8 seconds to get back to that point right there. And then who knows if it's going to make it all the way to them. But they're determined to wait, even if it takes over 20 seconds. So there's a situation. So what you have to do is you have to look at your situation, look at your variables, see which ones you have, and then choose the equation that that would fit the situation. So in this case, the first equation that we talked about, that we derived from here, would actually fit quite nicely. All right, so so that was just a quick little example problem of how we might solve a problem with a constant acceleration using the velocity final equals velocity initial plus constant acceleration times time final. So I'll do a couple more examples where I use the other two equations that I showed you in the derivative video.